Okay, so we are live. Please click on got it.
Good evening, everybody. So we will start my favorite chapter, and it should be your favorite also, surface area and volume. So first, let us get familiarized with some of the objects. Means you should have that practical knowledge, how it will look. So this is a cuboid. You know already how a cuboid looks, isn't it? This is a cuboid. This is just a box cuboid. Is it clear?
Yes,
So,
ma'am.
yeah, see, here one surface is there, here also. So, two areas are there. This is the bottom and this is the top. And this part, the longer part, it is the length, and the shorter one, it will be the breadth, like this, isn't it? See, this is length means this one. This is breadth. Length is greater. As a custom, we write length is a greater value as the length. Usually we represent by the letter L. So this is L and this is B. And what about this? This is height. Okay, this is regarding cuboid. So how many areas will be possible? See, this is the bottom area. Bottom area and top area, it will be exactly the same. Whatever bottom area is there, same value will be for the top area. Is it clear? Then these two surfaces and these two surfaces, these are the vertical sides or lateral. Lateral means side. See, if you consider a room, the walls are the lateral sides. Is it clear? And see, this chapter, this is practically very, very important. See, in the case of painting, a room is to be painted. A room is to be painted means walls are painted, isn't it? And sometimes in the question they will give the roof also, that is ceiling also is to be painted. So that is, you should understand the question. That is the main thing regarding this chapter. That is with the practical aspect. That is from your daily life examples, you should understand. So this is regarding area. So how many areas are there? Base area, top area. These are the vertical surfaces or lateral sides. Vertical surface area. Usually the word used is vertical surface area. This part, is it clear? Now we will consider volume of this. So what is the difference between volume and area? Area means it is, see, I will just give an example. Area, the room is to be painted. In that surface area, surface, lateral surface plus maybe ceiling also. But volume means what? Volume means how much it can be kept. See, in the box, see, in this box nothing is there. Coins, we used to keep coins. So how many coins can be kept? Or how many pebbles can be kept? Or something like that. What all things we can keep in that? What is the quantity inside? What is the capacity? So that is volume. Usually many children, they get confused area and volume. That's why I'm just explaining like this. Okay, see, for painting a room, you just consider this example. Most of my children used to understand like this. Painting a room means it is surface, not a total surface area, vertical surface area plus ceiling area, something like that. But there it is not volume. We are not filling paint in the room. Are we filling paint? No, we are not filling the paint, isn't it? So these are the formulas regarding our cuboid. Cuboid, or sometimes in the question paper they used to ask parallelepiped or rectangular block. Like that they will give. Now the main thing, see, one of the other thing regarding this surface area is this one, that is unit. So may I share the screen and write on the whiteboard? Okay, I'm just writing on the whiteboard so that, yeah. Okay, is it visible to everybody?
Yes, ma'am.
Okay, good. Okay, so in the case of base area, for this, which one? Rectangular block or cuboid. See, in the case of this cuboid, base area is what? L into B, length into breadth. That is base area. Then what about this is base area. Base area is equal to length into breadth, L into B. So L is one length unit. So it will be in centimeter or meter, something like that, isn't it? See, if this is in centimeter, this also is in centimeter, means centimeter square, square centimeter, or in general, you can write square units. So base area, that is area. The unit is square units. Now, what about vertical surface? Vertical surface we have already seen, or lateral surface, like these surfaces are there. So here what is the area? This one is length. So here only height is there. So this is L into H. Here also L into H. So this one is B into H. This is B into H. So how many see, this is L into H. This is L into H. Isn't it? So 2L into H. Okay, and this is 2 into 2BH. See, this part, this is base into height. So 2 base into height. So what is the vertical surface area? Vertical surface or lateral surface we can write. I am just writing VSA or lateral surface area. So here, how many lengths were there? 2L into H. 2L into H and 2B into H. Or we can just combine this and write 2 into H into L plus B. Or we can write 2 into L plus B into H. So what about this L plus B? What is it? 2 into L plus B for a rectangular block or the cuboid. Isn't it perimeter?
Yes.
Yes. So we got the general formula. That is vertical surface area or lateral surface area is what? Perimeter. Only in very rare cases this will be different. Okay. So mostly we can write like this. This is perimeter into height. So vertical surface area is perimeter into height. So this is 2 into L plus B into H. This part is it clear? Now we will see total surface area, TSA. Okay, TSC is equal to total surface area. In the case of this cuboid, we have seen here one area, here also one area, top area. This is bottom area, top area. So what about this area? This is 2 into, this is L into B. Like this, 2 are there. So 2 into 2LB, we can write, isn't it? So base area plus top area, it is 2 into LB. And what about here? Here this was plus TSA is equal to 2LB plus 2BH plus 2HL. See, I have written, instead of LH, I have written HL. That I will tell you why I have written like that. See here, what is the common factor here? 2. Isn't it? 2 into, so inside the bracket it is LB plus BH plus HL. LB plus BH plus HL. So those who are having difficulty in remembering the formula, you can just think like this. That is vertical surface area. It was 2 into, that is perimeter into height, that we have seen. In the case of total surface area, 2 into L, only 3 dimensions, 3 values are there, length, breadth and height are there. So first one LB, then L is replaced by B, that is BH. Isn't it? L is replaced by B, B is replaced by H. So it is BH. And in the last one, B is replaced by H, H is replaced by L. This type of expression, it will means you must have understood, you must have studied also. These are known as cyclic expressions. Cyclic. That is, we are just replacing it in turn. That is A by B, B by C, C by A. Like that, you must have studied in some formulas. So this is one cyclic form. So it will be easy to remember. 2 into LB plus BH plus HL. So all the means now we have seen base area, vertical surface area, and vertical or lateral you can write, and total surface area. Now in the case of this cuboid, only one is remaining. What is remaining? Volume. Volume is equal to, volume is capacity. In the case of vertical surface area, I told you perimeter into height. Same way for volume. Most of the solid objects we can tell volume is equal to base area into height. Base area into height. So what is the base area of cuboid? L into B into H. Isn't it? Base area is L into B, L into B into H. So the base volume formula is L into B into H. Now what about the unit here? L unit is meter or that is length unit, isn't it? So here the unit into unit, length unit into length unit into length unit. So length into length, or what we can tell, unit into unit, or meter into meter, centimeter into centimeter. That means it is centimeter cube, meter cube, etc. So what we can write this as cubic units. Cubic units. So area, that is, if you solve everything correctly and in the unit if there are mistakes, you will not get a mark. At least 1 mark will be gone there. So you have to be very careful. Area, it is square units, and volume, it is cubic unit. Now one more thing regarding this volume. Sometimes they will ask how many liters can be contained and all. So liters, if you want to, that is here now, if it is in centimeter, you will get a centimeter cube. Volume will be in centimeter cube. So if you want to convert it in liters, you have to divide by 1000. If it is in meter cube, you have to multiply by 1000. This last year also, in 9th standard also, you have studied this, isn't it? But we don't know. Sometimes they will ask in between some questions like this. That's why. So this part, I'll just clear the board now. Okay. Now, see, regarding this, that is cuboid now we have seen. Now, what about a cube? See, in cuboid, see, whatever be the height, base and length, if it is equal, all the 3 dimensions are equal, it is known as a cube. That much you know, isn't it? Are you aware of that? Yes, you are aware of that. So cube, quickly we will just see the formula for cube. Okay, this much explanation is not needed in the case of cube. So in the case of cube, what will happen here? The volume. First we will write volume. That is side into side. That means what? Side cube. Or if you are using the letter L, it will be L cube. That much you know, isn't it? Now this was volume. Sorry, volume. Now next one we will write base area. Base area, it is the easiest one. What is base area? Side into side. That is side square. Side square. Okay. Now we have to write vertical surface area. Vertical or lateral. It is the same. Vertical surface area. While you write vertical surface area, just like our cuboid. Okay. See, the only thing is all the dimensions, length, breadth, height are equal. Only that much is there. So only one L is there. L or A or that is side. All the sides are equal. Okay, that much you know. So this is the base part, base, top, then here 2 plus 2, 4. Isn't it? So totally, vertical side 4 are there. Vertical sides 4 are there. Lateral sides 4 are there. So what will be the vertical surface area? Vertical surface area will be what? 4 into side square. 4 into side square. Now, what about total surface area? In the case of total surface area, this 4 side square plus base and top. So, together, how many sides are there? How many areas are there? 6 into side square. Okay, so regarding cuboid, see why I'm see in your textbook, not much importance is given for cube and cuboid, but why I am explaining this, this is the basic. Not only that, sometimes mixed mixed type of question they will ask. One on top of that, something like that, that I'll show you one or two questions. So for that and all, this part, that is, you should understand is a basic. That's why I have explained this. Okay, so these formulas, I think you must have understood. Now we will go to our next part. That is very, very important in your textbook also. That part, much importance is given for that. That is regarding cylinder. So cylinder, you know already. See, this is a cylinder. Everybody, can you see?
Yes, ma'am.
Yes,
ma'am. Yes, ma'am.
Okay, okay. So this is a cylinder, but here in this cylinder, if there is a top, that is different. A lid. We can tell a lid is. Here I haven't shown any lid. See, this is the base, and here if lid is there, that will be the top, and this part, just like our vertical surface area, but this is curved, isn't it? Isn't it curved?
Yes,
isn't it? Yes, yes, it is curved. So instead of vertical surface area, we tell curved surface area. Curved surface area, CSA. Okay, now see in cylinder, in the case of cylinder, we are lucky. Only 2 dimensions are there, isn't it? In the case of cuboid and of 3 dimensions were there. Here only 2 dimensions. What is that? For circle. See, this part, the base part is circle. So what is this? Here this from this end to that end, diameter or radius, only one dimension. Diameter or radius, both are both are related ones. Diameter is given means we can find out radius, or radius is given means diameter. Like that we can find out. So for a circle, only one dimension is there. Not one dimension, only one quantity, one measure only is to be given. So that is radius. And what about this part? This is the height. This is the height. So radius and height, only 2 values. Only the 2 values we have, only 2 measures, not value exactly. 2 measures we have to consider. That part, are you clear? Are you able to understand that? Only 2 values are there. Radius. Yes. You want to ask something, Sri Krishna?
No, ma'am. No, ma'am.
No. I feel I am very lucky to teach one Krishna Bhagavan. His smile also is like a Krishna, very enchanting. Good. I feel very fortunate to see Krishna. Okay, so now see, in the case of cylinder, see this is a cylinder. My drawing is very bad. That's I have shown that, but here I have to show. So see this part, this is radius, and this part, it is height. And in the question paper, sometimes they will give an example, a cylindrical drum, something like that. Otherwise, they will give right circular cylinder, right circular or right cylindrical, something like that. In many problems, I have seen that word. But see, nothing to worry about that. The meaning is, whatever be the area, bottom area and top area, it is exactly the same. And the height is perpendicular. That is the meaning. Don't worry about that word right circular or right. In some questions, they give that. So this is radius and this is height. Only 2 dimensions. Only 2 the measures are there. So what about the base area? Everybody will be knowing that base area. Base area is what? Pi r square, isn't it? Pi r square, that you know. Now, see, instead of vertical surface area, I am writing curved surface area. Curved. It is curved. That's why CSA. Curved. CURVED we write. Curved surface area. See, curved surface area for cuboid and all I explained. There is a shortcut formula. What is that? It is perimeter into height. So I'll just explain with that. perimeter into height. Height is h, no problem. So what is the perimeter? For circle, what is the perimeter? Perimeter of the circle 2 pi r, isn't it? Isn't it? Yes, 2 pi r or pi d. About 2 pi r or pi d you can write. D, if d is given, pi d you can write. So 2 pi rh, perimeter into height. See, every time you just learn this shortcut formula also, curved surface area or vertical surface area or lateral surface area, it is perimeter into height. Okay, now what is to be written? TSA, total surface area, total surface area. I am writing TSA. Since I am very lazy, total surface area, but for the examination you write total surface area, like that you have to write, because some examiners, they are very butchers, very butcherous habit. They want to cut the marks. So maybe something like that, it should not happen. So we will write a TSA. This is just a shortcut only, TSA. So what is TSA? Total surface area is base area plus top area plus curved surface area, isn't it? So what is base area? We have already seen pi r square. See, this is base area. So top area also will be the same, isn't it? Base area and top area, it is exactly the same. Means same value, same measure, same radius is there. So same measure, same value. So pi r square plus 2 pi r h. So here, see, pi r square plus pi r square is what? 2 pi r square plus 2 pi. See, this was 2 pi r h. Okay. Pi r square plus 2 pi r h. 2 pi r h. So in these two terms, which is common? 2 pi r is common. 2 pi r into here, what is remaining? R plus h. And what is the unit? The square units, isn't it? Why it is square unit? See here, radius. Radius is the length unit that multiplied by h or r. This also is length unit. So one unit into other unit, it is square units. So this is 2 pi r into r plus h, or if you feel like h plus r, that is up to you. But see, while you learn by heart, some of the children, they will just rote and learning will be there. Instead of that, once you write the formula, then you keep it in your mind. So it will be useful. It will remain there forever. Okay, so 2 pi r into r plus h. Unit, you have to be very careful about the unit, square units. Now, what is the square unit? Okay, units. Now, what is then? This one, volume. Volume also, I told you, one shortcut formula. Every time volume, it is base area into height. Only rare cases there is difference. Cone, there will be difference. Otherwise, it is the same. Volume is equal to base area into height. Base area into height. Base area into height. So what is base area? Pi r square. Pi r square into h. So pi r square into h is the volume formula, and the unit is what? Cubic units. Cubic units. Or unit cube. Cubic units, meter cube, centimeter cube, etc. etc. Why it is cubic unit? Because r square. R square means unit into unit. Then again same h also same type of unit. So unit into unit into unit means what? Cubic unit. Did you get that? Did you get the idea? Okay. So
yes.
These are, if you have got any doubt, you just in between, you can unmute and ask, or otherwise I'll be just going on my bud. Okay. So you just, I'm very happy to teach. So I'll be going on telling. So this much you understood. Now, one very, very important, not one, 2-3 important, more important formulas are there. Then we will solve the problem. Now, next one, we will see about cone. Isn't it? Cone. Okay. After that, I'll show you that hollow cylinder also. Okay. Otherwise, we will see hollow cylinder first. Then we will go to cone. Okay. Hollow cylinder. See, now we have seen cylinder. Now, next one is hollow cylinder. See, See, this is a cylinder. This is a cylinder. Now, here, suppose like this, if you are drawing, see, this is a ring part. Sorry, ring. See, this is like a ring inside. See, it is not exactly a circle. Now, it is coming like this and here. But the same values will be there like this. This is the ring. This is ring, hollow cylinder when you are taking. See, now I have shown only, see, I have shown one cylinder, isn't it? See, that cylinder was hollow, but that thickness was very less. It was very thin. So that thickness we could not take. So if this part is thicker, if this is thicker, that will become a hollow cylinder. And here also, if it is hollow, or here if it is space is there, no problem. So this part or bottom part, it will be ring-like structure. Did you get it? Did you understand that part? So yeah. So that cylinder, that is whenever it is hollow cylinder like that, we have to take. So in the case of hollow cylinder, I'll just draw this a little more clean figure so that it will be more clear. See, I'll draw it once more. See, because that also is very important. See, down part. And here, this is the upper part. Here. So, thickness, we can show it properly. Okay. So, this part, it is thickness I have shown. See, this is height. This is h. That no problem is there. And see, this inner one radius, we will write smaller. See, inner circle is there. No, that is small r radius. And from here, this is the center. From here to here, this part we will write as capital R. Did you understand that part? See, it is like see, in the case of this hollow cylinder, that cross section, it is like a ring. Are you able to follow?
Yes.
Yeah, okay. Okay. So the inside one, it is smaller. That's why I have written smaller. The other one, it is bigger one. So capital R. Okay. Now, how we will write the, that is, the inner one, that is the internal radius. Internal radius, I have written as a small r. And the external radius, this outer circle, that is bigger one, I have written capital R. Okay, that is known as external radius. If you feel, if you want, I'll write that also. External radius. External radius, capital R, and internal, that is the smaller one. Internal radius, I'm writing smaller. Okay, so these two values, in the case of hollow cylinder, this is important. So now we will see, first we will see the volume. Volume is equal to volume of the cylinder. Cylinder in the sense that will be whatever part is here. That is that material, with which material it is made, that volume. Okay, so that is equal to volume of the hollow cylinder is equal to base area. So now base area into height we know. So instead of pi r square, we have to write the value pi into r square minus r square. Okay. See, capital R, ring area we have to see, take, that's why pi into r square minus r square, then height no problem. Okay. Now what is that? Now curved surface area. Curved surface area, we have seen it was what was curved surface area? Base, that is perimeter into height, isn't it? It was 2 pi r into h. In the case of cylinder, we have seen 2 pi r into h. But here we cannot write r here, isn't it? So R plus R. Only R we cannot write, R plus R into H. Otherwise, formula is the same. But here, don't get confused. See, in the case of volume, we have written R square minus R square. And here we have written R plus R. Because curved surface area, inner cylinder as well as outer cylinder, both areas we have to consider. Usually, children get confused here. They may make a mistake here. So, the other one, that is, in the case of volume, we have taken R square minus R square because only that with which material it has been made, that volume we are taking. But in the case of area, when we are considering the area, see this area as well as this area. Both area we have to consider. Okay, is it clear? See, I'll show you one more thicker. See, this is little more thicker. This is a hollow cylinder. So this area and the outside area, both we have to take. Is it clear?
Yes,
Did you understand? See, this is very important. This is very important. Okay, so that much we have seen. Now, curved surface area we have seen. Now, what about the other one? Now, only one more is remaining. That is what? TSA, isn't it? TSA, no problem. We will add both. Which all things are there? 2 pi r into, that is curved surface area is there. Curved surface area 2 pi r into R plus R into H plus. Now, what is the other area? The base area and the top area, isn't it? Base area plus top area also we have to take. Isn't it? In the case of total surface area, this is curved surface area. Isn't it? Now, what about the base area? Base is a, what is this? Ring area, pi into R square minus R square. This also pi into R square minus R square. Do you get that? Pi into R square minus R square. So how many are there? Base area and top area means 2 pi into, what is there? R square minus R square. There. Ring area is R square minus R square. So here 2 pi into R plus R into H. And here it is 2 pi into R square minus R square. Sai Krishna and Sri Krishna, do you have any doubt? No. Did you understand, Navya, Manjeri?
Yes, ma'am.
Okay. Understood, no? Okay. Okay. So this is 2 pi into R plus R into H and 2 pi into R square minus R square. So either you learn only this much, or I will just show you how to make the smaller formula, how to simplify this. That much also I will show you. So this is 2 pi into R plus R into H plus, this is 2 pi into, what is R square minus R square? Our identity, A square minus B square, A plus B into A minus B, isn't it? So this is R plus R into R minus R. So here 2 pi into R plus R is common. That's why maybe in your textbook formula is given like this. 2 pi into R plus R, that we are taking out. So here what is remaining? H is remaining. And here what is remaining? Capital R minus small r. So this is our short, final formula. But don't learn this by heart, or don't learn this without knowing. This much if you are able to write, then you will be able to do the problem. Okay, now we will see. This much I think you must have understood. Now we will see about the cone. So what is cone? Cone, see, like this shape, isn't it? Cap and all, it is, see, like this shape. So in the case of cone, now, see, this is smaller radius, down part it is circular shape. So this is R, and radius, this is what? Height. And this is L. L is the, what is that known as? It is slanting. It is slant height. It is slanting, isn't it? It is slanting. So it is a slant height. So slant height, one formula is there. See, this is by our Brahmagupta theorem or Pythagoras theorem. L square is equal to what? R square plus H square. Okay. Now cone base area pi R square. What about the curved surface area? A little difference is there here. This is base area. Then which one? Curved surface area. Okay, that is pi RL. That other formula will not work here because see, from the cylinder, this much part, see, cylinder is like this, isn't it? Cylinder means it will come like this, and from here, this much is gone. So directly perimeter into height, that we cannot use. That's why we are using the formula pi RL. So what about our total surface area? Total surface area is pi R square plus pi RL. So that is pi R into R plus L. So this is, now what about the volume? Volume also it is little bit different. It is 1/3 pi R square H. As for cylinder, from the cylinder, some part is cut out. So it is, the shape is different. That's why 1/3 pi R square H. Then unit, it is the same only. Volume means cubic unit, that we know. Okay, now our next one, frustum also I will explain. Before that, we will see for this one. Which one? Sphere. Okay, sphere. Sphere, no need of drawing. I'll show you the sphere. All of you know. See, this is sphere. Isn't it a ball or this type of object? This is the sphere. So sphere, only again, just like a circle, only one measure is there. What is that? R, radius is there, isn't it? No height, nothing. So what about a curved surface area? Curved surface area, base area, total surface area, everything only one is there. This much, isn't it? Only one is there. So in the case of sphere, only one area. No, we need not show base area, something like base area, vertical surface area, like that. We need not show. Only one area is there. And that is a total. If you want, you can write a total surface area. It is 4 pi. I'll write again. 4 pi R square. 4 pi R square. And volume. Volume is 4/3 pi R cube. Volume, it is cubical unit. So 4/3 pi R cube. Only two values are there. Two formulas are there. Now, if you cut this. See, if you cut one sphere, if you just cut the sphere into two, see, it will be like this. See, it is not exactly cut. Means if you open, this is just this one. See, this is not exactly half cut. If we are cutting it half, see, okay. So this is, if it is exactly half, it will be half of the sphere. Half of the sphere, how we will tell? We are not telling half a sphere. Instead of that, we use the word hemisphere. Isn't it? Hemisphere. So in the case of circle, half circle, what we tell? Semicircle. But here, half sphere. H-E-M-I. Hemisphere we write. So in the case of hemisphere, area will be what? But in the case of hemisphere, what will happen? How many areas will be happening? See this part. If this is this is the curved portion. Curved surface or vertical surface is there. And if it is a base, if it is this is a hollow sphere. If it is a if it is a solid sphere, like that one base will be there. So base area also we have to take in the case of hemisphere. So hemisphere, we will see hemisphere area, two areas are there. Curved surface or vertical surface area, it is half of this. That means it is 2 pi R square. And what about volume? Volume is equal to half of 4/3. Half of 4/3 is what? 2 by 3, 2 by 3 pi r cube. So this is curved surface area. So what about the base area? Base area it is pi r square. Therefore, total surface area. In the case of this hemisphere, total surface area also is there. So that is equal to what? 3 pi r square. Because 2 pi r square plus base area. That's why it is 3 pi r square. Okay. Okay, these are the formulas. Only one more is remaining. But in your examination point of view, sample paper and also that type of question is not there. But still, I'll just explain once. See, if the cone is cut, the bottom part we get, that is known as frustum. Frustum. See, top part. See, if a cone, I'll just rub this and I'll show you that also. That is in the case of a cone means we know. See how it will look. See, this is the cone. This we have seen. Isn't it? This is the cone. If we cut like this bottom part, see, it will be like this, isn't it? So this is known as frustum. F-R-U-S-T-U-M. Frustum. Okay, so just like our this one, hollow cylinder, we have seen many formulas, no? Pi r square minus r square and all. So here frustum also we have a little bit not complicated, but the formula is very lengthy. So see why it is lengthy, because here one radius is there, here also bottom part. See, bottom part one radius. That is bigger one. So that we will write capital R, and top part is smaller one. That we write small r. So two radii are there. So top area, bottom area, it will be different. Okay, so first we will see volume. Usually from this, they ask this type of question, volume. See, this is just paper glass and all. This is frustum shape. So sometimes they used to ask one a sweet dish is to be served in a function. How many, say 100 glasses are there? What is the quantity of kheer or something like that? Sometimes they used to ask this type of questions. That's why. Okay, so that is a frustum, that glass, paper glass and all, it is frustum. Okay, so now we will see volume. See, volume of cone, we know. What is the volume of cone? Volume of cone is 1 by 3 pi r square h. Isn't it? It was easy one. But here, not 1 r. Different, that is capital R, small r. Both are there. So the volume is 1 by 3 pi. It is common. Then instead of 1 by the other one, for cone it was 1 by 3 pi r square h. So here it is 1 by 3 pi into r square plus r square. Both r we have to consider, and capital R into small r into h. See, there it was only 1 by 3 pi r square h, but here only r square we cannot write. That's why r square plus r square, and for approximation we are taking, for accuracy, not approximation actually. For accuracy, we are taking R into R also, into H. So that is the volume formula. Mostly they ask a volume formula, but still we will see this curved surface area also. In the case of cone, it was pi RL. But here, we have already seen only one R is not, 2 R's are there. So pi L. The other one was pi RL or pi L into R. So this will be capital R plus small r. That is curved surface area. Okay. Now what is remaining? Total. Total surface area will be what? This one. Total surface area will be base area also we have to add. Base area is what? Pi R capital R square. Isn't it? Base area will be capital R square, that we have to add and find out. So, frustum, only thing is, see, curved surface area we got and base area we got means we can just directly add and write. That you need not, I don't think so. You should by heart it. Okay, so let us see one problem, not 1, 2, 3 problems. See, in your model paper, one question was there. Most of you must have seen that question. Okay, so I'll just explain that once. The question was, one question was like this. The curved surface area of a right circular cone. See, I have already told you, right circular means what? That height is perpendicular. That is the only meaning. See, in your sample paper, you must have seen that question in A section. I think it was in A section. The values given are curved surface area, curved surface area of cone. Cone means a right circular cone. It is given. That is cone. That is cone. So CSA, right circular cone CSA is given as how much? 12,320. 12,320 centimeter square. It is area, isn't it? So it is centimeter square. So CSA of the cone, it is given 12,320 centimeter square. Now the question was, if the radius of its base if its base radius is how much? 56 centimeter. It is given in the question. 56 centimeter. Find its height. That is the question. Okay. It is given. A curved surface area of the cone. In your sample paper, they have issued. They have published the sample paper. No, in that this question was there. Because how to do the calculation. Only I want to show you how to do this. How to do the simplification. Only for that I am writing this problem. So curved surface area of the cone is given. Then what is given? The radius it is given. What is to be found out? H is to be found out. Now what is the formula for curved surface area? I'll write here pi RL, isn't it? What is curved surface area of the cone? Pi RL. Pi RL is given as 12,320 centimeter square. Now, see, H directly we cannot find out. Cone means L square is equal to H square plus R square. So what we will write? Here from this we can find it because pi we know the value, R we know, R it is given, so L is to be found out. So every time whenever you do calculations, what you should do is, what is to be found out? L is to be found out, that you keep on one side, the other values you take to the other side. So that is 12,320 divided by, this was multiplication. So when it goes to the other side, it will go to division, isn't it? Operation will change. When it goes to the other side of equal to symbol, operation will change, not the sign will change. So minus is not because, see, when it is subtraction, it will become addition. Addition will become subtraction, multiplication, division, like that. That is operations are changing. So pi will come down and R also will come down. Now what is to be done? 12,320 divided by pi value. Sometimes in the question it will be given. Otherwise, the common rule for taking pi is, whenever there is a multiple of 7, you take 22 by 7. Otherwise, 3.14. See here, R is there. Radius. Radius is 56. 56. Isn't it a multiple of 7? 7 8s are 56. Isn't it? Isn't it? That's why we are writing 56 here. So this will get cancelled. How much? 8. 7 8s are 56. Isn't it? So 12,320 divided by 22 into 8. 22 into 8. Isn't it? So whenever 22 is coming in the denominator, you just, in the working column or in your mind, you can check, is this a multiple of 11? Most of the questions are, while it is coming for the examination, it will work out. Means it will be multiple of 11. So when you divide by 11, see 11 one time, isn't it? Carry how much? 1, isn't it? 11 one time, carry 1 time, isn't it? 1, isn't it? Is it going 11 one time? Is it going 11? No. Okay, see, we will do like this. Here I'll show 12,320 divided by 22 into 8. Isn't it? Isn't it?
Yes, ma'am.
Yeah, isn't it? Oh, okay. So with 22, when you cancel, because in 11, 22 will go. So this is 2. So most of the time, it will may go 1 time, isn't it? So here again 1 time. So carry 2. 22 how many times? 2 times. So this is 1120 divided by 2 into 8. Isn't it?
Yes,
Is this clear? Yes, yes. So with 2 when you cancel, how much it will come? 5. Then 6, 0. 5, 6, 0. 560. 560 by 8. 560 by 8 is how much? 560 by 8, 57, 70, isn't it? So we got the value 70. See why I have written the calculation on the board is usually whenever these types of calculations are there, whenever 22 is there, most of the time it will get cancelled. Means the other terms, it will be multiple of 11. So every time you just check that. Most of the time it will work. Okay, so in the working column, first you can check. So now we got L as 70. Now I'll just rub this board and I'll show H calculation. Actually, we have to find out H, isn't it? We have to find out H. Yes, find its height. So we know for a cone, see, for the cone is like this, isn't it? So this is L and this part, this is H and this is R, this is H. So this is 90 degree. So L square is equal to what? H square is, if it is a 2-mark question, you need not write all these steps. Okay. Directly also you can find out H square plus R square. Now what is to be found out? H is to be found out. So what you should do? H square is equal to L square minus R square. Okay. So H is to be H. We have to find out H. So you, most of the time, whenever bigger values are there, you use identity here. That is, this is L square minus R square. What is A square minus B square? See, I'll write here. A square minus B square is what? A minus B into A plus B, isn't it? Isn't
Yes,
it? Yeah. So what can you do here? This is L plus R into L minus R. L is how much? 70. L now we found out. So L is equal to 70. So 70 plus 56 into 70 minus 20, 56. 70 minus 56. 70 plus 56 into 70 minus 56. 70 plus 56. 126. Isn't it? 7 plus 5, 12. So 126. Isn't it? 126 multiplied by this is 14, isn't it? Isn't it 14?
Yes,
yeah. So this 126, 14 nines are 126. So this is 14 into 9 into 14. Therefore, H is equal to, this is square root is there, root. So root of 14 into 14. What is the square root? 14. 14 into 3. See, 9, isn't it? 9, root is how much? 3. So, 14, 3s are 42. So, it is 42 centimeters. So that is, most of the time, these types of problems, see, these types of problems, it will work. That is L square minus R square. This formula you use, it will be easy. This is just a 2-mark question. So you cannot waste so much time by calculating root, this, that and all. So it should be short, means maximum 3 minutes or maximum 5 minutes only you have to take for this problem. So better you use this formula, L square, root of L square minus R square. See, in this case, it is R square. That is the identity A square minus B square. So A plus B into A minus B. It will be very easy to find out the square root. That's why I suggested this method. Okay, is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Krishna, any doubt?
No, ma'am.
Okay. If you have got a doubt, you ask me. Huh? Okay, so this problem, this was one of the sample question paper question. Now another sample paper, another question was there. That also quickly I'll just explain. The question was internal internal and external radii. See, it was in section C. It was in section C. Question number I don't remember. 4-mark question. It is, the question is like this: the internal and external radii of a spherical shell. Spherical shell. See, I'll write spherical. SPHERICAL. Spherical shell. Spherical shell, it is given. Okay. So a spherical shell means it is a sphere like this. Okay. See like this, one sphere. Spherical shell, maybe coconut or whatever be, something like that, but coconut, maybe radius, internal radius, external. See, coconut, it is a good example for our sphere, isn't it? That the thickness is there. So like that also. Okay, so the internal and external radii. See, internal and external radii are given. Internal and external radii. So external radii will be more. External, it is not radii. External, it will be radius. Radii is the plural. That's why they have used internal and external. So internal radius, external radius. Internal radius, it is the smaller value, isn't it? It is smaller value. So we will write a smaller. Internal radius, we will represent by the letter smaller, and external by capital R. Okay, now what is to be found out? The question was like this: the internal and external radii of a spherical shell are 3 centimeter and 5 centimeter. So this is given. This is 3 centimeter and the other one is 5 centimeter. It is given in the question. Okay, respectively. It is melted. Melted means what? You know what is melted? Yes, ice melted, something like that, isn't it? So it is melted and recast. It is cast. It is reshaped into what? It is recast into a solid cylinder of diameter. Solid cylinder. See, this was a sphere. This was a sphere. It is recast into a cylinder. It is given. It is recast into a cylinder. It is recast into a cylinder of diameter 14 centimeter. Diameter is 14. So radius will be 7 centimeter. Okay, find the height of the cylinder. Height H. What is the height of the cylinder? It is given. So, see, in the case of volume problems, you understand, see, one basic principle. If you melt something and recast into something else, the volume will be the same. Volume will be the same. Did you follow that part? Did you follow that?
Yes, ma'am.
Okay. So, this one, spherical shell, the shell volume should be equal to volume of the cylinder. So what is spherical? This is a sphere. Spherical, sphere. How to find out the volume? What is the formula for sphere volume? Sphere volume, 4 by 3 pi r cube, isn't it? 4 by 3 pi r cube. So what is to be taken there? 4 by 3 into pi into, how to take that? 4 by 3. Here it is 4 by 3 pi into, but see, only how much is that thickness? Only that much we have to take. So we have to subtract this r cube minus r cube. Isn't it? Are you able to follow this part? 4 by 3. Because it is a sphere, 4 by 3. Then pi into r cube minus r cube. Why it is r cube minus r cube? Whatever thickness is there, that much only, when you melt it, only that much is the volume. That is the volume of the material. Any doubt, Sri Krishna? Any doubt? Have you got
No,
it?
ma'am.
Okay. So everybody, you understand this? If this is of metal, this is the sphere, and it is melted. So whatever material, that thickness is there, only that material we are getting. From that material, we are making the cylinder. Okay, so this volume is equal to cylinder volume. This part, is it clear?
Yes, ma'am.
Clear.
Yes, ma'am.
Okay. Then, so what we have to write now? So this 4/3 pi into r cube into r cube, isn't it? So this is equal to, I'll write the calculation here. 4/3 into pi value, we will take just like that, we will keep it here, pi. Afterwards, we will simplify that. R cube minus r cube. What is a capital R? 5. So 5 cube. 5 cube is what? 5 5s are 25 5s are. So 125. Isn't it? It is 125 minus what is small r? 3 3s are 9 3s are 27. 27, isn't it? So it is 4/3 pi into 125 minus 27. Now we have to subtract this. 125 minus 27. It is how much? 15 minus 7. 8, isn't it?
98.
Is it 98? Is it 98?
Yes, ma'am.
Okay, correct. So this is 4/3 pi. And 98. 98 is a multiple of 7. So can we write the value 22/7 for pi? 22/7 we can write, because 98 is a multiple of 7. So 98. So 7, how many times? 7, 1, 28, 14 times. Isn't it? Isn't it?
Yes, ma'am.
So 14 into 4 into 22/3. So 22 into 4, 88. Okay, 88 into 14/3. The last calculation we can do afterwards. So 88 into 14/3 is the volume of the what? Volume of the cylinder. 88 into 14/3 is the volume of the cylinder. Now, see, now what is to be found out? What is the volume of cylinder formula? Volume of the cylinder is what? Pi r square h, isn't it? Pi into r square h. So what is pi into r square? Radius, it was given 14 centimeter diameter, so radius is equal to 7. So pi into 7 square into h. Pi into 7 square h is equal to what? 88 into 14 divided by 3. See, these types of calculation, see, it is recast, etc., etc. In those types of calculation, you can do the calculation only. That is last simplification. In the last step only you do. Means little bit of simplification you can do and keep. Otherwise, what will happen is, see, 88 into 14/3, there itself, if you were to find out, if you make any small mistake there, that mistake will be carried over here, and every step you will lose a half mark, etc. So in order to avoid that, in the last step only, final answer, there only you do the final calculation. So here, h is to be found out, isn't it? H is to be found out. So what we will do is 88 into 14 14/3. This 7 square will come down, isn't it? 7 into 7. And what will happen for this pi? Pi is coming down. So 22/7, isn't it? 22/7. So this 1 7 will get cancelled. 1 7 will get cancelled. Then this 7 will get cancelled. This is 2. So 88, this is 4, isn't it? So 4 into 2, 8/3. So height is equal to 8/3 centimeter. See, you can just write 8/3, or if you want, you can write in decimal. Did you get the point? See, otherwise, if 88 into 14/3, there itself, if we were to do that, sometimes in the decimal, if any decimal point and all, if you make a mistake, that mark will be cut everywhere. So this type of this problem, why they have given in model and model paper is, I think, see this it is a recast, means that volume is equal. That concept is very, very, very important. Then another thing is, here the question is means both are there. That is, sphere is there, at the same time cylinder also is there. That is, these type of combined questions you have to learn. In your textbook also many combined questions will be given. So those questions are more important. Means from the examination point of view, those type joined, the cylinder is joined on this, that, etc., etc. Those types of questions are very, very important. See, while solving, you should give more importance to those questions. That is, you should concentrate more there. Okay, now if time allows, we will do one or two more problems.